Hi guys, welcome back. It's Professor Hank, and in this video I'm going to show you how to define and access arrays in your C++ programs. So this is for beginners, just so you can figure out how to declare arrays, how to put values in them, and how to retrieve values from them. So what's an array? We got to start off with some definitions first. What's an array? You can think of an array as a variable that holds multiple values. Right, so you're used to int x, double d, char c, whatever. These are variables that hold a single value. Arrays allow you to hold multiple values. They're like variables that hold multiple values. So how do you define these things? How do you create them? Okay, so to create them, you're going to need a few fundamental pieces of your declaration in the statement, right? So you're going to have a data type. Okay, that's one thing. Okay, you're going to have a name for the array, an identifier, that's another thing. And then you have to have what's known as a size declarator. Okay, and so what this does is it declares the size of the array. All right, so here's an example. Let's create an array that'll hold 4 integers. So if we're going to have that, we have to say, well, it's going to hold integers, data type int. Right, then we have to have a name. So we'll just call this nums. Okay, now if that's all we did, this would just be a single integer variable that holds one integer. But this is going to be an array. So we introduce this bracket notation. And inside of here goes your size declarator. So here we're going to say 4. Okay, so this is going to create an array of 4 elements. Okay, so this is size 4 in terms of how many elements it has. So you can think of it in memory as being, 4 little memory locations right next to each other. Okay, so you've got something that looks like this, and you can put a value in this first spot here, and then you could put a value in the second spot, and then you could put a value in the third spot, and then you could put a value in the fourth spot, right? It'll hold 4 values because it's like a variable that holds multiple values. And how many? 4. Why? Because the size declarator we specified was 4. Okay, now that's how you can create an array, and you can, for this size declarator, you can make this however big you need it to be. It just has to be bigger than 0, right? Because it doesn't make any sense to have a variable or to have an array that holds 0 values or negative values. So you're going to have an integer that is going to be used as the size declarator, right? This is going to be an integer. That's another thing to keep in mind, an integer. Because, what does it mean to have half an element or half a value? It doesn't make any sense to say, oh, well, this is an array of 4.75 elements. That doesn't make any sense at all. You can hold a value or you can't, okay? So the individual locations within the array, these individual cells here, these are known as elements. Okay, individual spaces or cells in the array are called elements. Okay, and to store, we should talk about how you put a value inside the elements. Okay, and how you get them out. To access the elements, you use what are called subscripts, or they're also known as indexes or indices. Okay, depending on what language you're dealing with, you could see those terms used interchangeably. Okay, so how do we put the 8 in there, right? Right now, there's just a bunch of garbage in the array. The array's been created, but we don't know it's there, just like any other variable. Until you actually assign something, it could be anything. So the way you put a value in the first element is you use an index. You just take the name, we reuse those square brackets again, and we put the index number. Okay, and the first element of an array is index number 0. Okay, so I would put 8 there. Now this is weird because a lot of you, especially when you're first learning arrays, you're thinking, oh, it's the first one, it should be 1. No, we start the counting with arrays at 0, and there's reasons for that, which you'll learn about when you start learning about pointers. Has to do with memory addresses and all that sort of stuff. But this is how the counting goes. You start at 0, and then the second element has an index of 1 or a subscript of 1. The third has a subscript of 2, and then the fourth has a subscript of 3, etc. Okay, so these are your indexes. The counting always begins at 0. The subscripts, also known as subscripts, they begin at 0, and they just go up by 1, until you get to the size of the array. So another way you could think of it is that the max value, the biggest, you start at 0 and end with, size minus 1, right? Or n minus 1, where n is the size declarator. N is the size declarator. Okay? So that's the basics of it. Now, once you understand that, then you can use the individual elements of the array just like you would any other variable. So, let's continue this. So nums1 is equal to 6. Nums2 is equal to 7. And nums3 is equal to, 5, right? So now, after these 4 statements have executed, this is what we have in memory. Okay, we've got 8 in the first element, 6 in the second, 7 in the third, and then 5 in the fourth. And remember, we start the counting at 0, and we end at n minus 1, where n is the size declarator. Okay, so those values are now in there. And the subscripts or indexes themselves, they must be integers as well, right? It doesn't make any sense to go to the 1.5 element. That's not a thing. So you can go to the 0th element, the 1th element, the 2th element, the 3rd element, etc. But you can't go halfway. It doesn't make any sense. It's nonsensical. Okay, so I put some values in there. Now I want to, access those values. I want to get them out. I want to do something with them. So here we're assigning values to the individual elements using subscripts. Okay. So now I want to get the values out. So maybe I'll just do something as simple as printing them out. So I'll say out num0, just like if this was int x, right? You could do the same thing, but here we're just having to say, well, in this package, in this variable that holds multiple values, essentially, in this array, we're going to get the value out that's located at 0, right? That's in the 0th position, that's in the 1th position, the 2nd position, and so on. So let's go ahead and see that in action. Go ahead and compile that. So you can see there's the 8, the 6, the 7, and the 5. Okay, so you can do with these elements anything you could do with a variable of that type, right? These are integers, so we can add integers together, right? So we can do num0 plus nums1, for example. Okay, and then I'll assign that to a variable that we'll call total. Okay, so what's going to end up in total? Well, what's in the 0th element? 8. What's in the 1th element? 6. So 8 plus 6 is 14. So if we see out total, we're going to see what? We're going to see 14. Okay, so you can do anything with an integer element that you could do with an integer variable. Okay, and this isn't just for integers. I mean, this goes for any data type at all, right? I mean, you could create a array of strings. Okay, so let's go ahead and do our pound include up here for the string data type. Okay, and my D seems to be sticking a bit. Anyway, so you can do that. You can do string fruits, say. Okay, and then we'll put 3 fruits in here, and we'll say fruits of 0 is equal to orange, for example. Then we could say fruits of 1 is equal to pear, and fruits of 2 is equal to apple. Okay, so you can use whatever data type you want, and the subscripts here, as I was saying before, they have to be integers, but you can also use integer variables for these. So let's say that I did something like this. Let's say that I said int I equals or int j equals 1. Okay, I could then turn around and say, see out fruits of j. Okay, or we'll start it at 0 for this example, okay? And if I do that, then we're going to see out, I mean, what's in J? 0. So what is J here? 0. So what are we going to see? We're going to see fruits of 0. So we're going to see orange on the screen at the very end, right? So we can do that. We could then update, right, J to say 1 and do a similar thing, couldn't we? Right, just change the contents of J, and then we're going to see, the fruit at the 0th position, and then we change J to 1 on line 43, and then we see pear as a result of the cout statement on line 44, because J now contains 1. And we could do the same thing, or we could do a similar thing. Let's update J to 2. And once we've done that, J was 0, then it was 1, then it was 2. So we went through and printed out the complete contents of the array, one element at a time. Okay, now if that's true, then we can combine this with a loop. I less than what? Well, not less than 3, okay? Because with this loop, this is only going to evaluate the true so long as I is less than 3, right? And, how many numbers, we'll do this with the numbers array. How many numbers do I actually have in here? I've got 1, 2, 3, 4. So what I'd want to do is I want to go through and I want to display num0, nums1, nums2, nums3. So I'm going to need that I to be 3 at some point. So that way I can do something like this. What I want to do is I want to print out the contents of that nums array. So I'm going to say nums I, and then put a little space there. Okay, so I need I to be able to be 3 also. So I either have to do this, or I have to say less than 4, right? Because 4 is not a valid subscript. We established that, right? What are the valid subscripts? 0, 1, 2, and 3. So less than the size declarator. Use that size declarator there, and we'll be sure to hit all of the elements of the array. Okay, and then I'll put move the cursor to the next line here. So, I mean, you can combine all of these different ideas to have very powerful effects. Arrays and loops, they go together like peanut butter and jelly. And then, of course, I could also do this with fruits too, right? But here, I got to change this 4 to something else, right? Because what's the size declarator for the fruits? It's 3, okay? So I can't, there's no valid subscript that's 3. The valid subscripts are 0, 1, and 2, so I got to stop 1 short, right? So long as I is less than 3, then we'll go ahead and see out fruit of I. So I will be 0, then it'll be 1, then it'll be 2. So we'll see out fruits of 0, 1, and 2. And then as soon as I is 3, well, there is no fruits of 3. So this will evaluate to false, and we'll never try to go past the end of the array. So let's go ahead and test it. All right, so there's orange, pear, and apple. Okay, so those guys, they go together. Arrays and loops, fantastic together. Okay, now the very last thing that I'll show you in this video is talking about what's the memory requirements. And I lied. I'm going to show you one more thing. Okay, so what if we wanted to ask the user to enter the numbers, right? So then we could do something like this. We can use a for loop again. Instead of having like 4 cin statements for each number, cin nums0, cin nums1, just use a loop. It's better. So I could do something like this: for int I equals 0, I less than 4, I plus plus. And then I can do something like, cout, enter a number, right? And then I could do cin nums I, right? And let's not forget that we want both those statements executing on each iteration of the loop. So we got to put them in a block here. And that's what we're going to do. We're going to have nice little happy cout and cin statements. Okay, so then this loop is going to go through and ask the user for numbers, right? And then whatever the user types is going to go straight into the array. So we can do that, and let me show you one more little trick. Well, we'll test this first, and then I'll show you one more little thing we can do. Okay, so once we've entered in all the numbers, let's show those numbers back to the user. So I'll just have a little cout statement here, cout, you entered, right? And then we'll do nums of I. Nums of I. Okay, and there was 4 numbers, right? The size declarator was 4. Okay. So let's test that out. We'll do one last little cout and nail here to move the cursor to the next line. Okay. So, enter a number. Okay, so enter a number. We're now here. We're at this loop right here, and we're sitting right there. So we're going to enter a number. So I will enter, I don't know, 9. Okay, so that got read directly into nums of 0. And so the next repetition of the loop happens. I'll do 2. That went right into the second element of the nums array. I'll do 5. That went into the third element. And then I'll do, I don't know, 7. Okay. So then 9, 2, 5, 7, because of this loop right here, all went directly into the array. And then with my next loop, I printed out the contents. Let's make it a little bit more fancy. Okay, you could do something. What if I wanted to say enter number 1, enter number 2, enter number 3? Well, let's modify this prompt a little bit. Okay, and we can say, I plus 1. And then we'll do a little prompt here. Why I plus 1? Right, it's a good question. I'm glad you asked. Because what's going to happen is it's going to say enter a number, and then it's going to display whatever this integer is. Well, what's I plus 1? I starts off at 0, right? So on the first repetition, 0 plus 1 is 1. So it'll say enter number 1, and then we'll see a little colon after that. And then, this will read into nums of I. Well, I is still 0. So it's going to read straight into the first element. And then on the next repetition, I is going to be 1. So then it'll say enter number, and then I is 1. 1 plus 1 is 2. So then it'll say 2, colon, and then it'll read into nums of I. Well, what's I? It's still 1, right? So it just I don't know, makes the prompt maybe a little bit fancier, right? So now you can see it says, oh, enter number 1, right? And then enter number 2, and then enter number 3, and then enter number 4, right? So, just makes your prompts maybe a little bit nicer. Let me show you one more thing, and then we'll talk about the memory. So you see here how I've got 4 and I got 4, okay? Let's say for whatever reason, I decided that I want to have a 6-element array. And so I got to change my code, right? Got a 6-element array, and I come down here and I'm like, all right, cool. I need to change this, right? And that's great. But then I forget to change this. Okay, what's going to happen? Okay, well, I'm going to show you what's going to happen. All right, I start entering my numbers, 8, 6, 7, 5, 3, 0. Okay, I enter the numbers. They all went into the array just fine, but I only see you entered 8, 6, 7, 5. Why? Why did I only see 8, 6, 7, 5? What about the 3 and the 0? Well, take a look at that 4. That loop's still going to end after 4 repetitions. So the I in this output loop here goes 0, 1, 2, 3, right? So those are the only 4 elements that we see. So what we needed to do, the mistake we made, is that we didn't update both of them. Okay, so that's a really common mistake that you can make. One way you can get around having to deal with that, or one way you can prevent that from happening, is to use a little named constant up here, right? So you can do something like this: constant size equals 6. Okay, and so then you use size as the size declarator there, and then you can go into your loops, any loops that depends on that array, change that 6 to that constant, and so now you'll only have to make one edit, and it'll update everything else for you, right? So let's say that I wanted to change this to an array that has 7 elements. Well, that 7 is going to percolate all the way down through the code. So that 7 is going to be used there. So that is going to create an array of 7 elements. It's going to be used here. So now this is going to ask for 7 numbers, because you're going to go from 0, 1, 2, 3, 4, 5, 6, right? And then our output loop, 0, 1, 2, 3, 4, 5, 6, right? Because as soon as I is equal to 7, this is going to evaluate to false. And so the last cout statement will never execute. So let's see that in motion. let's see that actually happening. So enter number 1, enter number 2, enter number 3, enter number 4, 5, 6, and 7, right? So now if you ever want to change that, all you have to do is make one little edit up here. I can say, oh, 3, and then, like I said, it percolates all the way through the rest of the code, so that way you're not going to have that error. Let's see here. Oh, problem was that I made 3 elements, and see here how it has 4. That was the problem, so we'll just change that back to 4. Okay, so let's do this one more time. Okay, so now we're back down in our loops to only having 4 repetitions, and it matches, it's perfect. Okay, all right, so last thing to talk about is going to be the size in terms of memory requirements. Okay, so you take a look at this array right here, right? So what we have is we have an array of integers that are 4 elements long. So you take the size of the data type, in this case a size of an int, right? Size of int is equal to 4 bytes, right? Now you got to multiply that times the number of elements that you have. Okay, each element is going to take up the number of bytes of the data type. So we had size, right? Well, size is 4. So this particular array is going to take up 16 bytes. Okay. Another example. What if I did a double nums, and that was 8 elements long? Okay, well, this is going to be the size of a double, okay, times, a size declarator of 8, because there's 8 elements. So size of a double is 8 bytes times 8 elements, 8 bytes times 8 elements. That's going to be a total of 64 bytes. Okay, and that's really all there is to it for declaring an array and accessing its individual elements, for sizing it, for figuring out how much memory it takes, and how you can combine it with a loop to do cool stuff, right? I mean, you don't have to write out, you don't have to copy and paste this 10 times. You can just use a loop. And so it's really, really, really powerful.